Find the end value after 9 years of a $400 deposit that accrues 6% interest compounded yearly, monthly, daily, and continuously. All right, so compound interest. We have two different formulas that we need to know how to use. The first says that the amount of interest is given by the principal by 1 plus the rate over the number of compoundings per year times the number of raised to the number of compoundings times the time in years. And that's what we'll use for parts A, B, and C. Yearly means that the n would equal 1, monthly means that the n would equal 12, and daily means that the n would equal 365. So part A, yearly, the amount would be given by the principal, 400 by 1 plus the rate is 6%. We write that as 0.06. The number of compoundings is 1, and then we would raise that to the 1 times 9 power. Now we certainly want to use a calculator for this situation. So I would type this in as 400 open quantity 1 plus 0.06. We don't really need to write the over 1, but I'm going to anyways here. And raise that to the quantity 1 times 9. We'll hit enter with that, and then round it to the nearest penny, $675.79. So now for the monthly, we would have A equals 400 by 1 plus 0.06 over 12 raised to the 12 times 9 power. And so notice I can just adjust what I did in the previous exercise. So I'll hit second, enter, that brings up my last entry, and I'll go to the 1 here, go to where that parenthesis is, and I will second insert a 2, and I'll do the same thing here, second insert a 2. Alright, so looks good. I'll hit enter, $685.48. Alright, now daily, instead of 12s, we'd have 365s. So we'd have 400 by 1 plus 0.06 over 365 raised to the 365 times 9. Again, I can hit second enter on my calculator, and I'll get rid of those 12s and replace them with 3, 6, and then I'll insert the 5 and do the same thing with the other 12. Overwrite with a 3, 6, and insert the 5. $386.37. Sorry, I forgot the number, $686.37. So notice that you might think, okay, well, daily it's compounding money every single day. Notice that that's not a huge change from the monthly. Right, monthly compoundings, we ended up with $685 over 9 years. Daily, it only rose up, less than $1 more, but we're having that many more compoundings. So it just turns out that there is a limit to the amount of money that you can get in this situation if the interest rate is held steady. And what happens is eventually the limit turns into what's called continuously compounded interest. And so for that formula, remember we have A equals P times e to the RT, where e is Euler's number, approximately 2.718. So for continuously, we would have A equals 400 e to the 0.06 times 9. And we would calculate that as 400. The e to the x is the second function of the ln button on the left-hand side. So we'd have e to the 0.06 times 9. Notice how it already brought up that parenthesis for me. So let me close it off, and I'll hit enter. 386.40. 686.40. Sorry about that.